Aloha and welcome. In this lesson, we're going to be talking about some engineering examples. We have two different ones here. One is going to be the gas equation. The other one is the trajectory of object on Earth. So these are, as you can see, engineering examples. They really aren't important for you to learn. It's just showing you how you can use some of the concepts that we've learned to actually write functions that solve these problems for us. So let me go ahead and share my screen with you. Where is my, oh, here we go. So the first one we have is the gas equation. We have gas constant. This really is open to a lot of jokes, so I'll let you do the jokes in your head, but we'll start with gas constant here. Gas constant is equal to 8.3144 621 joules divided by moles times Kelvin temperature. So we start off with a function, convert to temperature. We're taking pressure, volume, and moles as our arguments here. Well, these are the parameters. The arguments are going to be what's applied to it. We have a doc string here, and God bless them for putting that there. It tells us exactly what we're going to be doing. We're going to convert pressure, volume, and moles to a temperature. That lets us know what this does. And then if we look at the return, we're sending a singular value. It's going to be the pressure times the volume divided by moles times the gas constant. The jokes write themselves. So press equals float of input and our pressure in pascals. So what we're doing here is we're asking for the pressure. We're going to convert that to from a string to a float, and we're going to store that in pressure. Volume, we're doing the same thing. We're asking for it in cubic meters. It's going to convert that to a float, store it in volume. And then we're going to ask for the number of moles. We're going to convert that to a float and store that into MOLS, moles. This is the book's example. Notice that they did not do what they preach, which is to, kind of verbosely, I would think you would want to say pressure instead of just press, and then volume, just spell it out. You're almost there. So moles, one letter short, just put in the E for for crying out loud. So you want to have nice expressive variable names. So just go ahead and put that effort in there. If you've got something that's going to come out 20 or 30 characters, sure, abbreviate. But for something like this, I don't see the need to abbreviate to the degree that they have here, especially when they've talked about in the past putting nice long descriptive names on them. So that being said, I'll get off of my sandbox, and then we'll go down here to our print statement where we're printing a formatted string. We're going to say temperature equals. Then inside here, where you've got the expression that calls the function. So the function is convert to temp. We're going to send it press, vol, and moles that we just came up with. And then we're talking about here with the 0.2f, that tells us to go ahead and take our result and put 2 decimal places as a float here. So if we run this, we can run this and it will ask us for the pressure. Let's say we're going to have 1, the volume 2, and the temperature we'll say is 444. And when we hit enter, it tells us that the temperature is 0 Kelvin. So if we run this again, we put in, let's say 1, 2, and 3, it tells us that it's 0.08 Kelvin. So it is converting everything. So this is just how you go about making this arbitrary gas equation. The next example that we have in the book is where they're doing this for the trajectory of an object on Earth. I don't know about you, but this is something I'm always wondering about. So I've always been asking myself, how can I calculate the trajectory of an object on Earth? And wow, gee whiz, they've supplied that for me. I have to ask no longer because boom, here it is. Uncomment this code and look at it, and it tells us everything we need to know. First, we import the math module because we're going to need to be doing some things like cosine and sine here. So I want to point out that when we're calling on that, since we've done import math, when we're going to use things within math, we'll call on like math.cosine. And again, if you want to find out what's in math, you can always print out use the help function, the built-in function, and put math in there, it'll give you a list of all the functions that you can use. Over here, we can see that we're using the cosine function on a couple of occasions. And again, they have given us a docstring, which makes my heart go pitter patter. I love it, because later on, if we don't understand what we're trying to do there, it tells us verbatim, it calculates new XY position. Then we have the same over here, degree to radians. It has this wonderful docstring that tells us what we're doing, which if you really think about it is the same thing as the name of the function, but hey, redundancy isn't that bad. And it shows us we're returning a value here, which is the degrees times the math.pi. So math.pi is the value of the float value of pi, and then it divides it all by 180. So then it goes down and it does some math here. It sets gravity to 9.81. Time is equal to 1, x location is 0, and h is 0. And then it goes ahead and it starts asking us for our inputs for the angle, for the velocity, and the height. And then we go in here and we're just saying that we're going to do a loop while y loc is greater than or equal to 0. In other words, while it's above ground. We're going to print out the time here, and it has the formatting as well. And it's saying x is equal to the x location, then y is equal to the y location. And then we go down to the next line and we do an unpack here. Remember we did unpacks before? So we've got an unpack calling trajectory with time, angle, velocity, gravity, and height. So trajectory, which we have defined up here, we'll take those arguments. And again, TAVGH, not the best way of naming parameters, but what the heck. So it calculates everything for us. And again, you want to preface the function with the actual module that you're importing. And then here it's returning an XY tuple. Remember we said we could return two values in a tuple, a list, or other types of containers. And that's what they're doing here. So that goes back down here. And the result, it's the two pack that's getting returned. And we unpack it into X loc and Y loc here. And then we add 1 to time, and then we keep on going through this loop. So you don't have to understand what this is doing. I just wanted to show you that it's calling on a bunch of the concepts that we've talked about, unpacking, packing, if you will, here, returning more than one value in a container, using good docstrings, how you're actually using functions that are defined in a module that you import, and reminding you, even though I don't show you here, that if you wanted to find out all the things that are available in math, you could do a print of help of math, and that will give you the information that you need for this. So these are just some engineering examples that take into account a lot of the best practices and things like that we've learned. So you don't have to know any of this, honestly. It's just to kind of show you how you can go about building up functions that do the kinds of things that you're going to be needing to do. So if you're working for a business and they have their own special mathematical things that they need to calculate, you can do that, using the concepts that we've covered here. So this is a rather lightweight section, and that you don't really need to memorize anything in here. It's just really a good chance to get some hands-on experience, see the kinds of things that we've talked about and how they're doing it, like with it, whether it's the docstring or returning multiple values through a tuple. So that's what I wanted you to learn here. So anyways, again, if you have any questions, feel free to reach out to me in email, set up a Zoom chat. I'm happy to go through everything with you. We can share screens and do it that way. But in the meantime, I hope you've enjoyed this, and I'll see you in the next lesson. Enjoy.